Hello everyone, I'm Pablo Araya and with me is Vasana. Today we will be reviewing the challenges and solutions surrounding marking techniques for species in the order Urodela. As we dive into the world of salamander research, we've encountered a common hurdle wildlife researchers face, that being inefficient and non-invasive tagging and identification methods. There seems to be a lack of standardized protocols and a universal marking technique for all species. Traditional tagging often brings along some risks, such as harm, distress, and sometimes even changes in behavior. So the question we wanted to face is, how can we tag efficiently without causing harm or affecting behavior? Let's start with pigment injections. This method involves applying colored substances under the skin, creating a visible and lasting identifier for salamanders. The pros for this method are that injecting pigments under the skin provides a non-invasive method for marking salamanders with minimum harm and distress and does not seem to affect their behavior. Pigment injections can also provide a long-lasting visible mark that facilitates individual identification over an extended period. Different colors or combinations of pigments can also be used to code individuals. This allows for a simple visual identification method and lowers the possibility of recapture. Another pro is that it is also inexpensive in comparison to other techniques used. This method is also relatively straightforward and can be applied with minimal equipment. Researchers can carry the necessary supplies into the field without the need for specialized or bulky equipment, making this a practical choice for studies in remote or challenging environments. The cons for this one are that risk of local reactions or infections at the injection site are possible, and that pigments may migrate within the skin. This could potentially affect the visibility and reliability of the markings. On to the next, we're going to delve into pit tags. This technique utilizes small electronic devices used for identifying and tracking animals in various research and management applications. They are essentially high-tech identification cards for animals. The pros of this technique are that pit tags are typically inserted under the skin with a syringe. This minimizes physical trauma and avoids the need for surgical procedures. This can reduce the risk of infection or other health complications compared to more invasive tagging methods. Pit tags also have a lifespan that can extend for several years. This allows for prolonged monitoring of individual salamanders and long-term research projects. Researchers can use handheld or stationary readers to collect data from the pit tag salamanders without disturbing their natural behavior. The remote data collection therefore minimizes human interference and provides a more accurate representation of salamanders' activities. The cons of this method are that the range at which pit tags can be detected is limited, usually requiring a close proximity to a reader. This can be a limitation in large or complex habitats where not all tagged individuals may be regularly scanned. Another con being that acquiring the necessary pit tag equipment, such as readers and the tags themselves, can involve initial setup costs that may be a barrier for researchers who have limited budgets. Environmental factors such as water, metal, or dense vegetation can interfere with the effectiveness of pit tag readers, and this could potentially lead to missed detections or inaccurate data. As such, with the data retrieved from pit tags, it can be large in number and can be complex and require sophisticated database systems, leading to difficulty of managing and analyzing said data.
Another method we looked at was morphological differences. Morphological differences refer to variations in the form and structure of organisms, and these differences can be used for identification purposes, especially in taxonomy and classification. The pros to using morphological differences is that pattern recognition minimizes the need for invasive tagging methods by using natural color patterns as the primary identifier for each individual. The use of natural skin or fur patterns as markers has been successfully implemented with many different taxa. Another method, direct individual marking, may also provide a non-invasive and efficient method of identification. Each salamander will have a unique alphanumeric code that will be generated in the number of openings of repellent/toxic skin glands in the yellow areas of the selected regions of the body. The proposed method is inexpensive, easy applicable in the field, involves minimal animal stress, and does not affect their behavior and the possibility of repeated captures. In Figure 3, there are images of a fire salamander's body regions, with the skin gland openings used for generating unique identification codes. However, the cons of this method is that this may not apply to all species. This technique may also be very time-consuming to both prepare patterns and codes, but also to efficiently identify individuals based on morphological features. After reviewing the pros and cons of the three marking techniques, we conclude that the most effective method is pigment injections, as it is a non-invasive marking method that is long-lasting, clearly visible, requires minimal equipment, and is inexpensive, all while having little stress and not affecting species behavior. To improve upon this method, we suggest researchers focus on refining injection techniques for precision and minimizing invasiveness. Monitoring protocols and implementation methods should be standard to track pigment visibility over time. If possible, pigment formulation should be optimized to both reduce migration, but to also reduce chances for local reactions and infections. Below are our references. We look forward to answering any questions you have.